So here is a different method to calculate your player's path, and this is if your player has animations or it doesn't really depend on its angle. So in this case, I'll be showing you that. So this is how it works so far before I show you how the program works. So I'm the red character and I just move around. It points in the correct direction without in the angle, just with animations, and it stops within a radius and it stops at the right time with the right animation. So I can show you how it does that. So I have just all these variables here just for the code that I'll show you. So this is the same as last time. It creates that point that's essential for pathfinding or this path in general, pathway, and then this is calculating the direction as before, and then this is different. It just calculates the distance, like the Pythagorean theorem, because it's essential for what I'm about to show you, because I'm using the distance for when it stops. It stops when it gets too close on the distance. So I just set a variable called stop radius, which could be like 10 unity units away, and it will stop. And then it's idle. And then this is where I have like the idle positions. So like if the run, this is just, it starts running when the distance is far away. Like my run radius is 20 units. You can change it in the code. And this is the running, if it's running or not. And then this just makes it so it runs with the run speed. That's not as important. And all this is, it's just that all the logic below won't apply if this applies, like if it walks at a normal speed. But the important part is that is the fact that it gets the velocity from 0 to 1, which direction it's pointing, and if it's pointing at 0, its third idle state is has it's different, it's up, left, right, and down. And so when it's 0, you find that the case when the direction y is 1 and the direction x is 0, it's supposed to be an idle state 3, because that means that it's in the right of him, and this would be if it can be the right, left, but in this case idle state 3 is the same direction as when this logic is true. It's supposed to make it look right, it has to be an idle state 3. In my case, that would be this direction. Let's just say I were to move down here, it's supposed to move in this idle state. So you see it moves in that idle state, and then I move up here and it's in the left now. So it's up here, now it's facing up. Now it's facing up, and then when I go to the right, now it's facing to the right. So yeah, that's what that code means, and these are all the different cases when the velocity y is -1, and when it's 0, and all the time, because it has to be directly above it to go up and down. So the velocity x is 0 both times, so just when it's 1 and -1. And when the direction y is 1, idle state 3 would mean that it's above, and when it's -1, it's below. And break would just mean that that this stops once this logic is not true. And then by default, it's just idle state 1, which is the left and right. And then so this is where it just flips. So if it's on the left side or the right side, it will flip, which I made the flip function here, which is just basic vector 3s with its scale. And yeah, that's this code, which is actually a lot more efficient than what the previous code is if you want to have this specific type of character that's not pointy, and it doesn't really have any use for angles, just where it faces. So yeah, and you can also experiment with the different values that this character has. Like on the bottom, you could change its stop radius to 10. See, it will stop. See, like if I changed it to less than 10, let's say it was 5, now it can keep moving. So then and then the runs. Let's just say the regulars. Let's say the run speed was 20, and then the run radius is 20. So at the bottom here, see my distance is 2 right now, almost 2. And then let's say I run out of the way, and once it gets to 20, he starts to sprint. So, and then you can change all the values that I changed, like the radius to where it starts running, the radius to where it stops, and then the flip threshold is like the distance to where it flips, and obviously you'd want that to be the closest to 1 to 0. So I chose 0.5, which is correct, because you see when I'm past him, his change in x is 0. That means I'm right below him. So when I'm right past it, he switches. So it's absolute value, so I can account for the negatives more efficiently. And that's what this is really good about. And the signs makes it so it's 1 or -1, which is +1 on the y would mean that it's above, like this. -1 would be below. The right is positive x, and then negative x is on the left. And this is so I can tell. That's how I did this switch statement. Is 1 and 0 is if it's up or down, and like in this case, case 1 is like where if the y is 1, it's above, and then it's always 0. So it's like this. That case 1 is this, and then the other case is this. Yeah, so I feel like this code is very useful and efficient. So I feel like you should use it.